In this episode, we will be focusing on aspects within the extraction plant, from heat exchanger optimization to steam system improvements, all of which came to light to the insights and power of CoolPlanet OS. A focal point for CoolPlanet OS in extraction was a shell and tube hex that was one of the largest consumers of indirect steam in this stage of the process. As CoolPlanet OS was rolled out over multiple sites across this client's organization, one of its key benefits is being able to perform live benchmarking. Before our software went live, we targeted big energy users like this hex and installed additional instrumentation to capture an in-depth view of the process. This involved installing a dedicated steam meter alongside pressure and temperature sensors before and after the primary and secondary streams. Immediately when our software went live, instant savings were realized with no capex required. It was found that multiple sites with the same product throughput were consuming different levels of steam via the hex in question. After just a short analysis, it was found that each site was controlling the Mozilla stream at different pressure set points through the hex. The site with optimal running conditions was immediately replicated across the other sites, and the lowest savings achieved from this action was €53,276. By modeling the process around this hex and trending how it should be operating, it was found that there were further savings to be achieved as it was still consuming too much steam. The hex was increasingly becoming fouled between shutdowns where it will ordinarily be chemically cleaned. With the insight of CoolPlanet OS, we were able to pinpoint when and how the hex was fouling. On average, these circumstances only occurred 5 times a year, but had huge impacts on steam consumption. It was found that when the pump supplying the micellar was stopped, the steam supply was simultaneously stopped. This led to a pressure buildup within the hex, which burned the stagnant micellar to its walls, decreasing the surface area available to heat the micellar during normal operation. Because of this, an increased level of steam was consumed to reach micellar temperature set points. To negate this, a pressure relief valve was installed and would open the atmosphere when it received a signal from the Mozilla pump that it stopped. The minimum cost saving on each site for this action was €56,802. Lastly, on the hex, as with all the steam users on site, the mechanical steam trap was removed and a Venturi trap was installed along with the bypass circuit for easy maintenance. Most importantly, a blowdown valve was installed on the Y strainer protecting the Venturi steam trap. We find that on the majority of sites, the steam system may be suffering from corrosion, wear and tear to help keep the system clean and increase performance on indirect steam users. A maintenance schedule around blowing down these strainers will dramatically increase efficiency after a couple of months. This maintenance frequency can be reduced as the system becomes cleaner. Just in this section of the factory, the removal of mechanical steam traps and the installation of accurately sized Venturi traps, savings of €110,306 were realized. As with all the energy-saving measures taken, they can be scrutinized and followed live on a dedicated CoolPlanet dashboard. A complete thermal energy study was carried out through CoolPlanet OS, and it was found that there was enough waste heat available to satisfy some of the heat demands in extraction and, by doing so, decreasing steam use. New hexes were sized and installed in the micellar stream, which saved the plant €81,301. The largest user of steam in extraction is the toaster, as it consumes direct and indirect steam, again with the ability to easily benchmark across sites. The decision was taken to lower the dome temperature set point from 78 degrees Celsius to 72 degrees Celsius. This set point was reduced by 2 degrees Celsius every 24 hours. While our software was analyzing the parts per million of hexane in the meal output, ensuring it remained within acceptable levels. From this action, €326,726 was saved. Additionally, through CoolPlanet OS, we modeled the residence time taking place within the toaster and optimal steam consumption during the process. This led to many insights. Like so many other uses of steam, toaster was consuming in excess of what it should. With this knowledge, our engineers investigated further. After carrying out simple ultrasonic tests across the steam traps, it was found that the majority of them were not operating within their design parameters. Because the toaster is such a fundamental part of the process in extraction, the customer was at first reluctant to carry out any changes. However, with the insights and our software backed up by further tests carried out by our engineers, they felt comfortable allowing us to design and install new bespoke Venturi traps to replace the site's traditional mechanical traps. From this action, €123,811 was saved. Another insight that CoolPlanet OS was able to accurately provide from analyzing the extraction area of the factory was that not all of the condensate being produced was being returned to the degasser in the boiler house. This led our engineers to investigate thoroughly. All of the condensate generated was fed to a large collection header, which was serviced by a number of pump traps. This technology is based on motive steam driving the collected condensate back to the boiler house. The large pump traps would fill, and at a certain level, steam would be introduced to drive the condensate to its destination. The issue here was that steam was always engaged, which led to the majority of being vented to the atmosphere. To negate this, a new design based on the loads of this section of the plant was implemented, incorporating a condensate receiving tank with duty standby electrical pump set. This simple action saved the plant €36,570. CoolPlanet OS fulfills many functions, one of which is the ability to uncover optimization opportunities while giving the client all of the necessary feedback required to make a confident decision on the feasibility of these opportunities.